I have a question for you. Do you see anything wrong with this picture? I'm just looking at my desktop in the Windows File Explorer, and I can even minimize this window. Take a look. This is my desktop. I just have a Minecraft movie here, just a little 4K Pro release MP4 file to be able to watch the movie. But does anything else look weird? Let me change the view. You can get another perspective. I'll set this to a list, and, well, there's just all my files. What if we change the view to details? I'll scroll down. Can you catch it now? Do you see what's odd here? So just recently, Mandiant and Google Cloud, Mandiant, Google, Mandoogle, whatever you want to call them, had produced and released this threat intelligence blog titled Text to Malware: How Cybercriminals Are Weaponizing Fake AI-Themed Websites. Of course, I'll include a link to this in the video description, but I think it's worthwhile to highlight. Hey, big shout out, credit where credit is due to these authors and everyone involved. But the gist is that Mandiant Threat Defense has been investigating an uncategorized actor, uncategorized 6032, with the campaign that weaponizes the interest around AI and AI tools. In particular, those tools which can be used to generate videos based on user prompts. Obviously, all the hype with VO3 or whatever number VO thing is out now. The threat actors utilize fake AI video generator websites to distribute malware, leading to the deployment of payloads such as Python-based info stealers and several backdoors. Victims are typically directed to these fake websites via malicious social media ads that masquerade as legitimate AI video generator tools, like Llama AI, Canva Dreamlab, and Kling AI, among others. Apparently, there are thousands of these ads that have collectively reached millions of users across various social media platforms like Facebook and LinkedIn. Kind of crazy, kind of wild. It looks like it's actually able to pull a lot of the info stealer work there, exfiltrating logon credentials, cookies, credit card data, and Facebook information through the Telegram API. They believe this is a Vietnamese threat actor. Another cool thing is a little hat tip to Meta, who has been helping out with a lot of the Facebook end of this, and they also include a note for Morphosec, who has shared a similar investigation. Again, I'll try to be sure to include a link to this in the video description if you're interested. So for this video, I want to do a super quick crash course on this blog and write-up, and then zoom in to one of the interesting bits that I saw a lot of people chatting about. Look, realistically, everyone's hyped up about AI and artificial intelligence, so threat actors are taking advantage of that. You can see a lot of these ads that were shared either on LinkedIn or Facebook. Of course, Creative Pro AI, Luma Dream Machine, Kling AI, all to convert images to videos or text to videos with AI. But again, the shout out to Meta, looks like folks had to make this transparent, so we were able, or Google really, Mandiant and the crew was able to track this, look through them, and see what ads are doing what, including the ad library ID, how much it has reached individuals, etc. Neat. Won't fall down the rabbit hole too much here. I think we could zoom in to the malware. And there is a lot here, some things that we won't discuss specifically. So again, link in the video description. This will bring in a little bit of X-Worm, that'll bring in other backdoors. We've seen X-Worm before in plenty of other videos, and the other names that they might use for different things could, be another entity sample, etc. Some of the other neat things, though, they do utilize Tor to be able to grab other payloads, so it's all going through the Tor network for some external comms and activity. Of course, X-Worm sending stuff to Telegram, keylogger functionality, scanning for browser extensions for password managers, authenticators, and digital wallets, and the usual malware stuff. But these ads funnel you to AI websites. LumaLabsAI.in as one example, and then there are multiple down below, more with the Dream Machine, where you could click in to enter, type in text that you want to convert to a video, but it's all a lie. It's fake. It's going to provide you with malware. And an interesting thing, it looks like a lot of the files that it has generated, or so to speak, created for you, those are just ready to download archives that are already hosted on the same server with no connection to whatever you as the user type in. For that example of LumaLabsAI.in, a lot of those were available in the complete directory or folder within the web root, and it looks like it will end up serving the archive with the most recent, last modified value. So if the threat actor adversary were to update this, it would just end up providing that new payload, giving that to the user. And then this is where I think it gets a little interesting. The downloaded zip archive, if the user were to follow through the steps, type in the text, enter, generate, and get an quote-unquote AI-generated video, it's just a zip archive, but it contains a double extension file, something that has a .mp4 to look like a video and a .exe in its name, separated by Braille pattern blank Unicode characters. And this is to hide the actual .exe extension and push it way out of view so that it only looks like the .mp4 file is there. I know this is silly, I know this is stupid, but the thing is, it kind of works. Given that example, Luma Labs' whatever nonsense number with a handful of spaces will make the binary less suspicious by pushing that extension out of the way. They also include using the .mp4 Windows icon to make it look like it is a pure, real, genuine video file. They include a screenshot here so you can see with the given sample. And again, I know this is not sophisticated or sexy or leet or hacker cool, zero cool, Dade Murphy, whatever, but it's unironically kind of neat and good and would be effective. I did see just some light chatter about this on Twitter, X, the Everything app, noting just that simple, stupid thing will probably work well. And big shout out, I think Austin Larson was the first that I saw to share the article and get that out and about. Another from VX Underground just laughing at, unironically, this is a good idea. It's unbelievably stupid and it works. Depending on the Explorer layout, the .exe might not even be visible. And what I tried to show you previously, well, it wasn't there. Folks laughing and giggling, look, I didn't even see, I missed the .exe on the first glance. Facepalm. Others are noting, look, if you have the File Explorer view set to small icons, you only see the ... ellipsis at the very end. It's crazy. Stupid, but clever. And of course, some folks are saying, look, you know, this isn't new by any means. There's nothing new under the sun. It's not novel. They've used this previously. Other actors have done this, but it's still a trick. VX Underground memeing about this again. Be a Vietnamese threat actor. Need to infect folks. There's too much security layers, so we get an idea. Oh, 0 days, too much effort. Social engineering, well, it's a little bit risky. What if we just add a boatload of spaces to the end of the file? Now, forgive me, I'm going to speed run through a lot of the article because I do want to touch on it, but I don't think it's the focus of this video. That Starkvale executable is a dropper written in Rust, so might be kind of neat to try to reverse engineer. Looks like it just displays a blank screen and error, as if you were to execute it so it fails to play the video. Then they walk about, discuss the attack chain, a little bit of Python in the mix with some encoded little encryption, tricks to be able to work with that as a launcher, and then sideload a malicious DLL, which is neat. Some of the indicators of compromise that they touch on here are interesting. Again, that side-loading DLLs from a legitimate executable, establishing persistence with registry, just a simple auto-run entry. That's not, again, sexy or leet, but it will work. Some of the other payloads end up doing some neat anti-VM and anti-analysis tricks where they end up checking for sandbox DLLs or analysis tools, like if Cuckoo Sandbox is present, etc. Checking the BIOS, checking if this is running allegedly inside of a virtual machine, making sure the parent process is CMD, or if it shouldn't be, etc., etc. Just cool things. Maybe this would be a worthy element in cyber deception if you do any, not to say honeypots, but little landmines, little mouse traps for actors, and even using Tor for a lot of its communication. Just cool, neat stuff. I don't mean to just scroll through the write-up though. Again, I'll leave a link for that in the video description. I think you should check the rest of it out. But for this video, I want to discuss how we could put together our own stupid file with multiple Braille pattern block spaces in the name. And then let's automate that so we could do this kind of en masse or in bulk. I know it's one thing to just copy paste when you try to rename a file manually, but what if we could do this with a little bit more power with PowerShell? Let's start scripting in PowerShell and make that our adventure for today's video. So I'm going to open up PowerShell ISE and let's get started writing just a little script for us to try to pad a file name. I'll put this on my desktop so we can see it, pad filename.ps1, and let's get started. But wait just a second before we do, please let me give some love and support to the sponsor of today's video, Anti-Siphon Training. And really, Black Hills Information Security and that incredible tribe of companies that all do great stuff in our industry. Whether it's training with the pay forward what you can training, or a lot of their pen tests that they do, support that they offer for blue teams, etc. Anti-Siphon Training and the whole Black Hills Information Security tribe of companies is phenomenal. You know, I'm a fanboy. I do really like John Strand and all the great work that he does, and he has built built an incredible team to showcase a lot of awesome on-demand courses, live training, of course, the Wild West Hacking Fest conference, and just their incredible effort in the industry. I love the student testimonials here. Hey, we got Michelle from Huntress. Thanks so much. That's where I work. That's my day job. I work at Huntress. But of course, red team courses, blue team courses, hands-on labs with a cyber range, certifications, and all that great stuff. Recommend you take a look. There's a link in the video description. And if you wanted to drill down into the pay forward what you can, look, honestly, you can set a price tag as low as $0 for yourself. But if you did offer some effort, some compensation, then that will be forwarded along to the next folks who can't. So really, really cool model here. Hey, you know, I love the anti-siphon training crew. They have a phenomenal mission and they're doing it the right way. A lot of incredible instructors from all over the industry. And look, it is a true tribe of companies doing great stuff. So hey, link in the video description. Hope you check them out. Big thumbs up, big thanks to Anti-Siphon Training and BHIS. All right, back to ISE in our PowerShell script. Let's start to build this out. So if we were building a flexible script, it would be worthwhile to take in some parameters. So I'll define a param block up top here, and I do want to have one mandatory parameter. So we'll define a parameter with mandatory equals true, and that should be a $ prefix because we are in PowerShell. That's how we denote different variables. And then the type that I want to accept for the file path that we could provide would be a string inside of the square braces here to denote the type, and then file path being the variable that I want. We'll do the same for some other things that we'd like, maybe a new base name. So if we were given a file, we could end up, actually specifying, I want that to have a different name. Like if we were to work with an actual exe or program, an executable on Windows that could bundle in our malware, well, we want that to now look like an MP4 file, video file, or anything else that we'd like. But if we wanted to specify the new extension to really still be a .exe file or anything else that we wanted to change it to, let's make sure we have support for that as just as well, another argument optional that we could control. Then realistically, we want to make sure that the file exists. So let's use an if statement, just a conditional here to check. If not, exclamation point prefix that all within our parentheses, test path as the commandlet to make sure the file path that's provided as the first mandatory argument even exists. If it doesn't, then let's just simply write an error, file not found at that file path. And then let's exit 1 to make sure that that is going to be an error. Next up, we want to find the full path of this file. So let's actually store that as a variable. Let's say full path can be the result of this resolve path commandlet based off the file path that we provided. And then let's actually split it up to get the directory. Because, well, hey, we know the full path that we have. Let's try to get the chunks out of it so we can get the base name and then the kind of original name, really, the original name that this file started with. Now, I'll use some of the little system io.path within square braces thing, so that way we can actually use whatever those neat little .NET managed functions are. And we're looking for get file name without extension, based off our full path variable there. Let's do the very same for the old or original extension, and we can say that that is the very same sort of system IO path trick, but we'll actually call the function get extension. Nice and easy. Of course, passing in, once again, the full path that we've tracked down now. Now let's work with the base name of the file, and we'll have to check actually if we're providing a new base name and eventually new extension that were these optional set with nothing or an empty string by default in our parameters. So let's actually do sort of an inline check. Let's just test if the new base name is not equal to, PowerShell uses that -ne or other logic with the dash little parameter kind of thing there. If it's not equal to an empty string, then it should be, well, just the new base name that we provided in the argument. Otherwise, whoa, sorry, zoomed in a little bit too much there. Otherwise, we'll add the else statement where it can just be the original name, right? Because that's all that we kind of care about. We'll do the very same thing with the extension. We can test if the new extension was actually provided as a parameter, and if it is, we'll use that new extension. Otherwise, we'll use the original extension. Does that make sense? Now, ultimately, we will end up padding out the file name because we want to be able to take any regular file and its file name and then pad it out to hide what could be a new extension or that .exe for a program application and payload. Now, the way we can represent that Unicode character, because again, that's what they reference here. Let me go back to the top of this blog that showcased that. We see that that is using the Braille pattern blank character, or Unicode representation of it with hex 2800 and UTF-8 using hex E2A080. They include this hex dump here where we could see that all represented in the raw bytes, but if we wanted to recreate and craft that, well, we could just use 2800 as a character representation, denoting that Unicode value for the Braille pattern blank character. So that's simple, right? It's a character type, and then we'll actually specify it to be hex 2800. Now, how far can we pad this out? They used a size of, I think, 13 spaces following it, but we could probably determine, okay, what is the maximum length of a file name in Windows? Well, realistically, it is 255. I think in some, whatever, NTFS extended attributes, you can do some other crazy wild things with different kinds of paths, but not super duper necessary for our showcase here. That's just an anecdote. And let's say the extension with dot is where we could provide and at least make sure the extension that we're going to work with includes the dot prefix there, right? So now let's try to pad it, first by determining what the actual pad length should be. Let's use an initial pad length to do a little bit of math. Let's take that max file name length and then subtract the length of the base name that we'll end up working with. And then we'll also subtract the length of the extension with dot that we're working with. And we're doing that math as a quick check to see, okay, is this file already too long? Is the file name over 255 characters, which would be more than what Windows would be able to kind of handle? If that initial pad length is less than 0, right, if we've been subtracting too much, then we'll have to just error and notify, okay, we can't work with this file. The base name and extension is already too long to pad, greater than max file name length characters. And of course, again, we'll exit 1 if that were to fail. Okay, but now let's actually generate the padded file name. And this shouldn't be that hard, right? We should say, okay, the pad string is actually going to end up joining together, ultimately a string or a list of strings that are empty, right? So I'm using string type and then another square braces here, but I'm actually going to loop from 0 up to the initial pad length that we have minus 1. Just so we don't break anything there. And then let's say for each object, so we can actually loop through each of these and represent that pad character or the Braille pattern thing that will actually make up our spaces here. Oh, and I think I have accidentally moved some parentheses, so that should be how that ends. Because the string needs to be generated right there, but then we fill each position in that string of that length with the pad character, right? Now the padded name will actually be our base name that we were working with, including the newly generated pad string with the extension with dot. I know that's a little bit messy, just cramming all those variables together, but it will work. Now let's determine the new full path so we put it in the right place. We're going to end up joining together the directory that we worked with, that we started with, and now our padded name. So that should do it. Like, these 3 lines are the thing that basically end up determining the new value, but then we need to actually rename it. Before we do that, again, kind of running into if we're testing the limits of what the Windows file system will let us do for different file name lengths to maximize hiding with this Braille character. Well, we also need to keep in mind the length, the maximum length for a full path, not just a full file name. And now I could be wrong. I'd love to get schooled in the comments. Let me know. From what I understand, if you were using like that NTFS extended attributes file system thing shenanigans, you can get like a crazy long file name that's over like 32,000 characters long, or file path, forgive me. If we want to keep, not to say backwards compatibility, or really just the structure and strength that Windows should naturally let us do as a safe fallback, the top is just, I think, 260. So if we took our new full path length and then we were testing the max path length. Knowing that that were 260, we can do 259 to be safe. If that's the case, we should try to tighten or trim our file name so we don't clobber and hit that max path length. So I'll show you that. Sorry, enough of me trying to speak it out loud. Let's say if our new path length is greater than that max path length, then, well, we need to handle that case. Let me zoom in a little bit more here because we are getting close to that logic. Let's determine with some math the allowed name length. Like, where do we find the sweet spot where we are not over 259 characters? Well, let's take the max path length and subtract out what is the length of our directory, because that's the beginning of the path. Add a 1 there. Again, I'm just kind of keeping things to make sure we'll have some room for error. And then our extension with the dot length. Now that we have that value, we could actually check, okay, how far along or how close to that do we get with the pad length? What is the pad that could be allowed there? How many space bogus characters can we add? Our allowed name length should be subtracting the new or real actual set base name, since that's now been set to the property and the parameter that we provided. If that is too big, if we cannot trim or we cannot do anything, let's do our allowed path testing if it's less than 0, just as we did previously. If we're subtracting or working with too much here, usual error, right error, directory path too long to apply any padding, exit 1 there. But still in this broad if statement, let's try to trim it down. In case we need to, if our max length is just not where we're reaching, then let's try to get the same exact logic here using the initial pad length, like, okay, the maximum that we could work with based off what we've given thus far. But if we can trim it down, or if we need to, then what we'll do is actually change this value here to be our allowed pad length, now that we've figured that out. That's just regenerating the length of the string, the length of the file name, all working with the same structure that we had previously, but now making sure the directory file path is accounted for in its length just as well. That's really tough to say out loud. I don't know if that makes sense. Hopefully the code does. All right, now finally, we're just about done. Let's actually rename the item. Let's actually rename that file. Let's say the literal path that we were working with should be the full path that we have here, with the new name being the padded name variable that we've just prepared. Then we can add a nice little stupid right host success hello, file successfully renamed to, and let's add like a new line here with backtick, and backtick is the escape character in PowerShell. Let's make that green so it looks like a nice success color, and then let's actually write host and write out the new file path, right? That's it. 55 lines, just about, to at least automate that process and not have to do it hand jam with the mouse manually, just pasting in a bunch of Unicode characters. Oh, actually, I think I have a typo. This allow name length is missing the allowed with ed at the end here, and that not being a variable that exists, PowerShell would probably just interpret as a 0, in which case this condition would probably always hit. So sinister bug, little dangerous typo there. Oh, and another one down below. I'm displaying in right host echoing out new file path, but I believe we've been using new full path as the name of that variable, because that is the actual everything, including the directory and the padded info. So I think now, I hope we're good. Let's see this in action. I'm going to open up the command prompt. I'm really just running PowerShell using the Windows terminal here, and I will be getting into PowerShell, and I'll move into my desktop. That is where I do have our pad file name.ps1 script to work with, but we need a file to work with. And of course, if this was make-believe malware, it should be an executable, a program or an application to run. Just as a proof of concept, something simple, something small, something easy, let's use calc. Let's use the Windows calculator application, just calc.exe out of C Windows System 32. I see that present in my current directory, but now with the name calc.exe, let's see if we can hide that executable extension, but make it look like something else with our giant, long, stupid bunch of spaces. So let's use pad file name, and the file path that we can provide should just be the calc.exe in the current directory. Now remember, all the other arguments and parameters we could provide were optional. This is just a mandatory one that we need. That's how we wrote the code. But we could say the new base name could be like, oh, calculator.jpg or something. And then if we wanted to be super explicit, we could say new extension should just be exe, and we won't include the dot here, bear in mind, because our script handles that for us. So if I hit enter, file successfully renamed to calculator.jpg, and then a boatload of spaces to eventually hide the .exe file here. That extension means that if I go to my desktop, we still see our calculator.jpg, and I don't know if you can see it, but the highlight here is hysterical. It has .exe way down over the bottom. The other Minecraft movie example that I had does do the very same. I just seem to hide that because you can see now that one's not active and it hides the .exe, but it will add the ... and ellipsis to show that that is truncated. Double-clicking calculator.jpg obviously opens up calculator.exe because it is a .exe. It just has all that nonsense and junk there. Let me create just a new folder for us to see that purely in Windows Explorer. We can call it like test or whatever. And then if I move calculator.jpg in there, you'll see exactly as we saw in the Mandiant and Google write-up. And they're using calculator.jpg where the .exe is not included because it's going to be pushed out beyond what Windows Explorer would naturally show. And of course, we've got this file super long in the file name. But of course, the type clues you in, this is an executable. This is an application. It's a program. So for our original example, I used the Windows Media Player, WM player that's present on the Windows file system, just so we could have this icon. Because of course, using a actual executable file, you can't tamper with or change the executable file icon unless you use like Resource Hacker or do anything else, and that will break oftentimes the signature. So bear that in mind if you're putting together or staging your own malware or little test here, proof of concept, then you'll need to set the executable icon to be what you want it to be and look like. Of course, they use that in the example where it would simulate looking like a real MP4 or audio or video file. But that is our PowerShell script. And that is how we could now en masse automate this. You could run this through a ton of other files in a directory or as many other things as you'd like to bake out. But the next question is, how do we detect this? Putting on our blue team little defender hat, well, you have a pretty easy identifier here, right? If the user just didn't see it in Windows Explorer or inside of a zip archive like we saw as an example, even with the large icons, you might miss it. But obviously, just having a bunch of stupid spaces or Braille Unicode characters in the file name is something to key off of on its own. So if we wanted to detect this, it should be kind of simple. We can use Sigma, right? That language or sort of at least structure and YAML outline for detecting things off of logs. And if we're using the event tracing for Windows or E2W, then we could use Aurora, that quick and easy, free, or at least an Aurora Lite option to be able to, use Sigma rules that could eventually funnel into a SIEM solution or anything else, but at least we've got a capability to play with it on the endpoint. So I have downloaded Aurora Lite. I do have a license for that free option that's able to give me and you, if you want to go take a look. And with it downloaded, I have it available on my desktop in just the Aurora folder. I'll drill down into the custom signatures folder because that is really where I want to work. We'll create our own new detector based off of the template that they provide. So let me just make a copy of this and we'll rename that to be like Unicode file name or whatever. Of course, .yml extension. And we can open that up in something like Sublime Text or a text editor. Now, obviously, the detector here is extremely easy. And of course, this is just kind of, funsies, education's sake, watered down and distilled, but suspicious process execution of an application with Braille pattern block characters or whatever. We can call this as you would like, generate a new GUID if we want, experimental status. Description, we could toggle to really be whatever. Again, just for the sake of showcase, you could fill this in realistically if you wanted to. But the detector is simply looking off of probably the image, the binary or the program, or what's fired and executed on its own, or we could use like command line or any of these others. Image is probably going to work fine for us, but if you wanted to widen this to the command line, you are welcome to. And then the filter that we're looking for, well, it doesn't need to end with anything. We want something that contains the specific strings. And, well, we could probably just make a list here, and we could use the Unicode representation of 2800 or the UTF-8 representation that we know previously. However, I think this might get a little bit weird and wacky because then you're relying on either the logs to normalize the Unicode character or represent them in that way and your potential seam solution. So if we wanted to see this in action, I think I've had the most success with actually just including the Unicode characters themselves. So if I right click to like rename this file, then I could actually copy and move around my mouse cursor, but let me just grab one of these Unicode characters. Small, stupid, again, I'm adding as many disclaimers as I can because I'm sure there's plenty of ways to quibble and complain about this, but your mileage may vary. This is kind of just for the showcase, right? Doesn't need to be critical severity, maybe medium or whatever we're thinking, but let's see if we detect just this. Small, simple, and easy. So let's get back to our terminal, and then I want to go ahead and actually move into that Aurora directory. We have everything present here with all of these specific files and the license, but ultimately I want to run our Aurora agent. I'll use the 64-bit one, and I'll use hack P to specify the rules path, just so we don't end up loading in all of the other signatures and rules that it already includes. Let's just use the custom signatures where we know that we made our own specifications there. I'll hit enter on this, and yep, we can allow that to run. Now, with Aurora Light firing up, we should be able to see it good and in action there. Let's get back to our desktop, and let's try to run our Minecraft movie 4K Pro Release MP4 .exe. Double-clicking on this, oh, you can see it fired. And it's a little bit messy over there. Obviously, it's detecting all of those Braille pattern character spaces in Unicode, and it shows that all there. So that could be cleaned and could be made better. But on its own, we've seen, okay, a process run with that sketchy little syntax as part of its file name. Nothing fancy. No leet hacks, nothing too sophisticated. I know it's dumb, but it's clever and it would work. And maybe an exercise for the reader if you want to make this better, improve, don't even use this rule, but there are probably plenty others out and about that do similar things with odd Unicode characters. Obviously, there's so much more you could do. Right to left operator, or any of the strange characters and what they might do to file names on Windows. But I thought this one was cutesy and a worthy story to share.